news article details a serious incident involving electrical shock injuries on a lake. It serves as a stark reminder of the dangers associated with using extension cords improperly, especially near water. The incident occurred when a boat motor struck a 110-volt electrical extension cord that was run underwater to a nearby dock. As someone exited the boat and touched the water, they were immediately knocked unconscious by the electroshock and submerged. 2 others were also injured when they attempted to rescue the first victim. This unfortunate event underscores several critical points about electrical safety around docks and water. Firstly, extension cords, especially those not rated for outdoor use, should never be submerged in water. Water is an excellent conductor of electricity, and any break in the cord's insulation can energize the surrounding water, creating a significant electrocution hazard. Secondly, using standard indoor extension cords in outdoor environments is inherently dangerous. These cords are not designed to withstand the elements, and their insulation can quickly degrade when exposed to sunlight, rain, and temperature changes. This degradation increases the risk of electrical shock. Thirdly, ground fault circuit interrupters, or GFCIs, are essential safety devices in any location where electricity and water may come into contact. A GFCI constantly monitors the current flowing in a circuit. If it detects any leakage current, even a tiny amount, it will trip the circuit, cutting off the power almost instantly. This can prevent serious injury or death from electric shock. In this incident, it's not clear whether the outlet supplying power to the extension cord was GFCI protected. However, the presence of a GFCI could have significantly reduced the severity of the injuries. The National Electrical Code, or NEC, provides specific guidelines for electrical installations in and around docks and marinas. These guidelines are designed to minimize the risk of electric shock drowning. Electric shock drowning, or ESD, occurs when an electrical current passes through the body while the person is in the water. The current can paralyze muscles, making it impossible to swim or even keep your head above water. The NEC requires that all electrical outlets and equipment installed on docks and marinas be GFCI protected. It also mandates the use of wiring methods and equipment that are specifically designed for wet locations. Furthermore, the NEC addresses the issue of equipotential bonding. Equipotential bonding involves connecting all metal parts of a structure, such as a dock, to a common grounding system. This helps to ensure that all metal parts are at the same electrical potential, reducing the risk of voltage differences that could cause electric shock. When working with electricity near water, it's always best to err on the side of caution. Firstly, never use extension cords as a permanent wiring solution. If you need to provide power to a location on a dock, have a qualified electrician install a permanent code-compliant wiring system. Secondly, use only extension cords that are specifically rated for outdoor use. These cords are designed to withstand the elements and are less likely to develop insulation faults. Thirdly, inspect all electrical cords and equipment regularly for signs of damage. Replace any cords or equipment that are cracked, frayed, or otherwise damaged. Fourthly, never overload electrical circuits. Overloading a circuit can cause the wiring to overheat, increasing the risk of fire and electric shock. Fifthly, keep electrical equipment away from water whenever possible. If you must use electrical equipment near water, be sure to keep it elevated and protected from splashes. Sixthly, be aware of the signs of electric shock. These signs can include tingling, muscle cramps, difficulty breathing, and loss of consciousness. If someone is experiencing electric shock, do not touch them directly. Instead, disconnect the power source or use a non-conductive object, such as a wooden stick, to move them away from the electrical source. Seventhly, know how to perform CPR. CPR can be a life-saving skill in the event of electric shock or drowning. It is always recommended to take a certified course to be prepared for these sorts of situations. Let's delve deeper into the technical aspects of electrical safety in wet environment. The NEC, specifically Article 555, addresses the requirements for marinas and boatyards. This article covers everything from wiring methods to grounding and bonding requirements. One of the key requirements of Article 555 is the use of ground fault protection for all electrical circuits serving boat hoists, boat lifts, and other equipment that is likely to come into contact with water. The NEC specifies that ground fault protection must be provided at a level of 30 mA. This means that the GFCI must trip the circuit if it detects a leakage current of 30 mA or more. This level of protection is designed to prevent serious injury or death from electric shock. Another important requirement of Article 555 is the use of corrosion-resistant materials for all electrical equipment and wiring installed in marinas and boatyards. Salt water is highly corrosive, and it can quickly degrade electrical equipment that is not properly protected. The NEC requires that all electrical equipment be listed for use in wet locations and that it be made of materials that are resistant to corrosion. In addition to the NEC requirements, there are also several other safety standards and guidelines that should be followed when working with electricity near water. The American Boat and Yacht Council, or ABIC, develops standards for the design, construction, and maintenance of boats and yachts. These standards cover a wide range of topics, including electrical systems. The ABIC standards provide detailed guidance on how to install and maintain electrical systems on boats in a safe and code-compliant manner. The Occupational Safety and Health Administration, or OSHA, also has regulations regarding electrical safety in the workplace. These regulations apply to any employee who works with electricity, including those who work on docks and marinas. OSHA requires that employers provide their employees with training on electrical safety and that they provide them with the necessary personal protective equipment, or PPE, to protect them from electrical hazards. PPE for electricians typically includes rubber gloves, insulated tools, and safety glasses. In addition to following these safety standards and guidelines, it's also important to be aware of the potential hazards of stray current corrosion. Stray current corrosion occurs when electrical current flows through the water and into metal parts of a boat or dock. This current can cause the metal to corrode rapidly, weakening the structure and potentially leading to failure. Stray current corrosion is often caused by faulty wiring or grounding on boats or docks. It can be prevented by ensuring that all electrical systems are properly installed and maintained and that all metal parts are properly bonded to a common grounding system. To summarize, firstly, never use extension cords as permanent wiring. Secondly, always use outdoor-rated cords. Thirdly, inspect equipment regularly for damage. Fourthly, do not overload circuits. Fifthly, keep electrical equipment away from water. Sixthly, know the signs of electric shock. Seventhly, learn CPR. Eighthly, adhere to NEC Article 555. Ninthly, follow ABIC standards, and 10thly, comply with OSHA regulations. The incident described in the news article serves as a powerful reminder of the potential consequences of neglecting electrical safety precautions near water. By following the guidelines and recommendations outlined above, it is possible to significantly reduce the risk of electric shock and other electrical hazards in these environments.